Hey everyone, and welcome to the course. My name is Daniel Buckley, and I'll be your instructor. So, in this course, we are going to look at augmented reality and more specifically AR Foundation inside of Unity and how to set that up so we can actually build our very own AR app to our device. So, first of all, what we need to talk about is what exactly is augmented reality? Well, augmented reality is basically adding virtual objects into the real world. This can be stuff such as 3D models and maybe even measurements. This is not to be confused with virtual reality. Virtual reality is creating an entirely virtual environment around you, whereas augmented reality is just augmenting your existing one. Now, AR technology is very versatile as it can pretty much be used in any sort of field. It can be used in games, education, industry, as even now there are a wide range of AR apps that cover a wide range of different uses. And something else you should also note is that augmented reality technology is fairly recent, and especially AR Foundation, which we're going to be working with. This sort of technology is new and it is going to continue to grow as phone technology improves. So now what is AR Foundation? Well, before we go into that, I reckon we should first talk about what the two main sort of AR SDKs that are out right now. The first one is AR Core, and this is augmented reality for Android devices. This allows developers to create AR apps for Android devices. And then over on the iOS side, Apple has their AR Kit, which has the same sort of principles with augmented reality, but with iOS devices. So what AR Foundation does is it gives the Unity developer an API so that they can actually develop for both platforms seamlessly. They don't have to have separate projects for Android, one for iOS. They don't have to be switching between the different APIs and SDKs. It's all in one package where you can just develop for AR and then build to either iOS or Android or both. So how does AR Foundation actually work inside Unity? Well, first of all, what it does is it uses your camera and depth sensor, and with that, the app creates things known as feature points. These are basically points that points of interest in the world that it can track. It can track its position, its orientation relative to other points as well, and this sort of maps out a rough 3D sort of mesh of your world so that it understands how far away things are and the position between different feature points. And with this, the app can then create horizontal and vertical planes that map out real-world surfaces. As you can see in the image, it can track the floor, it can track walls, and with this, we can do many things. The app can also track the device's position and orientation in world space, so you can actually then walk around your environment, and in fact, it memorizes and catalogs the environment and feature points. So what you could do is you could go into an entirely different room, look around the walls there, set that up, and then go back into the other room, and all those feature points and objects that you placed down before will still actually be there. Okay, so that's how it works, but what can we actually do with AR Foundation? Why should we use it? Well, with AR Foundation, we can, first of all, of course, track surfaces, and with these surfaces, we can detect raycast hits and place objects. As you can see in the image to the left, there's objects that are being placed down on these surfaces, and they'll actually stick there, so you can walk around them, and they will stay in the exact same position. AR Foundation also has lighting estimation, which means that your AR models can actually adapt to the lighting around you. So if you're in a dark room, then your models will become darker, and if you're out in the sun, your models will be bright. And this is really good in creating immersive experiences, as you don't want the lighting to be off, and of course, this technology will only get better as time goes on. There's also environment probes, and this allows you to accurately map the lighting conditions and reflections inside of your environment. So if you have a shiny object or something metallic, you can actually see your surrounding environment sort of reflect off of that object. AR Foundation also has face tracking, so you can track people's faces and apply masks, really whatever you want to their face. And then there is 2D image tracking. This is useful for maybe if you're maybe making a promotional app. You could have a movie poster or a game poster, and you could have your AR app look at it, and then out from that poster could pop a 3D model, an animation, or something like that. So with this collection of various different features, you can really make any sort of AR app you can think of at the moment. And of course, as time goes on, this technology is only going to get better, and there is definitely going to be many more features that are going to be added to AR Foundation and AR Core and AR Kit in the future for you to use. Now, on the screen here is a link that will actually take you to the AR Foundation sort of manual page on the internet. This just goes over the features and sort of explains more about AR Foundation and how it works. Now, there is one sort of downside to AR Foundation, and that is not all devices are supported. Since this has fairly advanced AR in using depth sensors and actually being able to capture, map out the world around you, it does require a certain level of device. So, first of all, for Android, you need a minimum Android version of 7.0, and all phones, including the Galaxy S7 and above, can work with AR Foundation. And of course, all Pixel phones work as well. On the iOS side, the supported phones are the iPhone SE and the iPhone 6s and more recently. So pretty much all devices from the past few years should be working fine with AR Foundation. But if you want to make sure, you can go to these following links, which will be down in the lesson summaries, to make sure that your specific device does actually work with AR Foundation. Zenva is an online learning academy with over 500,000 students. We feature a wide range of courses for people who are just starting out or for people who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to follow the online video tutorials, or you can choose to read the included lesson summaries. There's even the included project files so you can follow along with the instructor. So now that we know a little bit more about AR and AR Foundation inside of Unity, let's now go and create our first AR app inside of Unity using AR Foundation. Welcome everyone. In this lesson, we are going to be setting up our Unity project so that in the future we can easily just jump straight in and get working with AR Foundation. So here I am inside the Unity Hub, and the first thing we want to do is make sure that we have either the Android or iOS build platforms installed. So I'm going to go to the Installs tab here, find my Unity version that I'll be using, and then click on the little three dots here, then go Add Modules. And you need to make sure that you either have Android here with Android SDK and NDK tools enabled and installed, or iOS build support enabled and installed. You can just enable this, then click Done, and that will begin installing. I'm using Android for my example because I am working on a Windows PC, so building to iOS is not possible. But if you are working on a Mac computer, you can build to iOS. So make sure that you have those either the Android or the iOS modules installed. And then we can go to projects, and then we can click on the new button right here and create our new Unity project. Alright, so here we are inside of Unity. To begin, let's go up to File, Build Settings, and inside of this Build Settings window, what we want to do is first of all switch over to our desired platform that we want to build to. This can be either Android or iOS. In my case, I'm building to Android, so I'm going to select the Android platform right here. Now, you do need to make sure that you do have either the Android or iOS platform installed as a module onto your Unity version. And do know also that if you are working on a Windows computer, you cannot actually build to an iOS device. So only on a Mac computer can you build to iOS. So in our case, we're going to be building to Android. So select your build platform right here, and then just click on Switch Platform. It shouldn't take too long since we do have an empty project, so this should pretty much go ahead pretty fast, just like that. And now, as you can see, just doing a bit more here. And now, as you can see at the top here, it says Android instead of PC, Mac, and Linux standalone. Now, the last thing we want to do here in build settings is click on the Add Open Scenes button right here to just add our current scene to the build settings, as this is the scene that we want to launch when we actually play the game. So we can close out of that now. And what we want to do is actually import the packages that we're going to be using for this app. Now we need to first of all install the AR Foundation package, and then also either the AR Core or AR Kit plugin, depending on what you're going for. Remember that AR Core is the Android AR system, and AR Kit is the iOS AR system. So let's go up to Window, Package Manager, and inside of the Package Manager here, what you want to do is just wait for all the packages to load here, and we want to install first of all the AR Foundation package, so we'll just click on Install here, and this just has all the basic features of AR Foundation, connecting the two SDKs to Unity, and being that actual in between between your app and the two SDKs, just so it's fairly easy and straightforward to actually develop for both, whereas you don't have to have separate projects if you're working for iOS and a separate project for Android. You can all work in the exact same project using AR Foundation. Now, like I mentioned, if you're working on Android, you need to install the AR Core XR plugin right here. Or if you're working on ARKit, so iOS, you install the ARKit XR plugin here. We're working for Android, so I'm going to install the AR Core XR plugin here. Just click install. And also, if you do want to, publish for both, maybe you could install both of these plugins as well. Okay, now that we have that installed, we can get out of the package manager here, and let's just set up some of the actual player settings for this app, because when we build it, we need to set up a few things. So let's do it now. So we'll go Edit, Project Settings, and inside of the Project Settings window here, we first of all want to go to our player settings, and in here what we can do is set up a few things. First of all, for the company name, this isn't really necessary, so you can have this as your company or just have it as the default one here. For the product name, this is what's actually going to be showing on the actual app. The little icon, this is going to be the name of the app, so I'm just going to call this our AR Foundation Intro. And down here then in the Android settings, or iOS if you have that enabled, we can skip over resolution and presentation since we don't really need to mess with anything in there. In other settings though, what we need to do is enable Auto Graphics API. We also then need to come down here to our package name and fill this in. This is basically our unique identifier for our app. So the way this normally works is you have com, then dot your company name, then dot your product name. So I'm going to replace company here with Zenva, and product name here with, we're just going to call this AR Foundation Intro. Now, you can call this whatever you want. It doesn't have to be tied to a specific company or product. This is just a way to uniquely identify your app on your device. Something else we also need to set is a minimum API level for the app, as we don't want this running on devices that can't actually support it, and it is a requirement. So we need to set our minimum API level here for Android. We need to set this to 24. So down here, Android 7.0, we'll click on that, and there we go. The rest of the other settings here should be fine. Down in XR settings, you may see that it says AR Core supported. Now, we don't need to enable this as we are using AR Foundation technically, but if you are creating a app that is just using the AR Core SDK and not AR Foundation, then you would have to enable it. But since we are going through AR Foundation, we don't need to tick this. Now, something else we also need to do is go down here to where it says XR, and it says you must create a specialized instance of the settings data in order to modify the settings of this UI. So we'll just click on create here. It'll ask us to save this somewhere, so we'll just save it right here. And there we go. And we just want to change this from required to optional. Now, with that all set up, our app is pretty much ready to go. If we were to plug our phone in and build this to there, we would see that the app works. But nothing really would happen because we actually haven't even set up anything for AR at the moment. So the way we can do that is by right-clicking here in the hierarchy, and we need two things for this. So let's go XR, and we want to add in an AR session origin. This basically defines the center of the world. This defines the origin, and if we click on this, you'll see that it has the AR session origin script right here. And as a child, it also has a camera. Now this is the AR camera that is what you'll see. It will be rendering what your camera sees behind it, and any sort of AR features inside of Unity will be on top of that. There's a few scripts here that manage all that. So what we can actually do is delete the existing main camera right here. And let's change this AR camera's tag to main camera, as this is now the main camera. Now along with this object, we also need to have a XR AR session right here. This is what maps out our AR world. And with that, we are pretty much done. In the next lesson, what we're going to do is set it up so that we can actually see the planes that are being detected and actually learn how to build this to our device. So I'll see you all then in the next lesson. Welcome back everyone. In this lesson we are going to be going over how to set up our AR app inside of Unity to work with Android, and then after that we're going to go over how to actually build this to an Android device. So first of all, what we want to do is change our build platform to Android, because right now, as you can see here at the top, it is PC, Mac and Linux standalone. We want to switch this platform over to Android. So let's go File, Build Settings, and make sure that you do have the Android build platform installed. We went over this in the previous lesson of how to actually set this up, how to install it into your version of Unity. So select that, then just click on the Switch Platform button right here. It shouldn't take too long. And after that is done, let's also add our current scene into the scenes in build list right here, as this is going to be all the scenes that we are going to be able to run inside of our app. So we'll click on Add Open Scenes, and there we go. We've got our scene added to the build right here. Okay, we can then click on Player Settings, and this will open up the Player Settings window right here with a bunch of things that we can change. First of all, we can change our product name, and this is what the name of the app is going to be. The little icon, this is what the app is going to be called. So we could just call this one our AR Foundation Test. It's really up to you. You can call this whatever you want. The company name, that's not really too important. If you do have a company name you wish to put there, then you can, but I'm going to keep it like that for now. Then down here, what we're going to do is change a few things as well. Let's open up other settings, and what we want to enable is Auto Graphics API here. We then want to go down to where it says package name, and in here what we want to do is basically change this to our unique identifier. Now, a package name for Android is basically a way for the device to uniquely identify your app, and the format for this is normally com.yourcompany.name your product name. Now, this doesn't have to be strict. It's not going to check to see if your company name is really that or anything. This can really be whatever you want. So here I'm going to go com.zenva.intro to AR Foundation. Okay, there we go. Version we can keep the same, but something we do have to change that is actually a requirement with AR Foundation is to change the minimum API level right here. We got to change it from the default 4.1 Jelly Bean, and we got to change it to API level 24, which is Android 7.0. So we'll change it to that there. And apart from that, we really don't need to change anything else. You might see that down here in XR settings, there is this thing called AR Core Supported. We don't actually have to enable this, as this is really only needed if you are building a app that is just using AR Core. Since we're using AR Foundation, we don't have to do this. But what we do have to do is click on XR right here and click Create and just save it. Really anyway, we can just save it here in our Assets folder and change requirement to optional. This is just something we have to set up for AR Core. And apart from that, we are pretty much done. We've set up everything we need here. If you do want to, you can go to Resolution and Presentation and change if we are allowed to go Portrait Mode, Landscape, Portrait Upside Down, or Landscape Right. You can change those if you wish, if you only want it to be played in landscape mode. Splash image, this is just what appears on the screen when we start up, as well as a Unity logo. So you can add your own logos here if you wish. And publishing settings, this is really just for if you're publishing it to the Play Store, so we don't really need to look at that for now. And yeah, that's really all we need to do. So let's click on the X right here. But we can't click build and run just yet, and the reason why is because we need to set up our device first of all to actually work inside of set up our device so we can actually use it with Unity, so we can actually build projects and transfer the files over to our device, because by default that is not allowed. So let's go over to our Android device right now and I'll show you how to enable developer options. Okay, so what you want to do is you first of all want to go to your settings on your mobile device. Then you want to scroll right down to the bottom to About Phone, and then in here we want to click on Software Information. In here what we want to do then is just tap on our build number here 7 times. So 1, 2, 3, 4, 5, 6, 7. And what this does is we then have to enter in our current PIN, and then developer mode has been enabled. So we can go back to our settings, and if we scroll right down to the bottom, you'll see that we now have developer options enabled. We can open that up, and in here what we want to do is scroll down to USB debugging here. We want to enable that, And what this will allow us to do is connect our device up to our computer, and it'll allow us to build Unity games directly to our mobile and add that as an app. That's pretty much all we have to do on our phone. Now all we need to do is connect our device to our computer. Okay, so after you've done that, we should go back to Unity here, and you just want to find where it says Run Device. You want to click Refresh, and if you open this up now, you should see that you have your Android device right here, so we can select that, and then we can hit Build and Run. You can choose a location to save this APK. I'm just going to save it here in our Intro to AR folder. Now the name of this doesn't really matter, as this is just the name of the file, not the name of the actual app. So I'm just going to call this one our app right here. Hit save, and then it is going to start to build to our device. Make sure your device is plugged into your computer, and once that is finished, it should then automatically pop up on the screen, and you should be able to test it out. In the next lesson, we're going to be going over the exact same sort of thing, but with iOS devices and how to set it up for that. So if you don't have an iOS device, you can just skip over that lesson, but if you do, it's recommended that you do watch that lesson, as there are many steps that do differ from building to Android, so we do need to explain them when we're over there. Apart from that though, I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to be looking at how to actually export and build our AR project to an iOS device. So first of all, let's go File, Build Settings, and inside of Build Settings we want to switch our build platform over to iOS. So I'm going to select iOS here, and then click on the Switch Platform button. It won't actually take that long to convert over to iOS, so once this finishes, we can then begin to edit our player settings. Now let's go over and click on the player settings button to go over to the player settings window. And in here, first of all, let's change our product name. This is what will appear on the app icon. This is going to be the name of the app that will appear on your device. So you can pretty much call this whatever you want. And then let's go to other settings down here. First of all, we need to make sure that Auto Graphics API is enabled. And then we can go down here to Bundle Identifier. This is a unique ID for all Apple products. This has to be unique as well, so the normal format is com.yourcompanyname.yourproductname. This isn't restricted, it's not going to check to see your company name. This can be pretty much whatever you want. You just have to make sure that it's unique. And then down here we have to enter in the camera usage description. This is just going to explain to the user what they're going to be using the camera for. So when they have to enable it, it'll pop up saying enable to use AR Foundation. That's what we're going to say. So enter that in right there. And after that, we can scroll down, and we have to change the architecture here. You got to change this from Universal to ARM64. And down a bit more, we can then go to the XR tab and click Create. This is just going to ask us to create a new ARKit settings. And once that's done, we can change the requirement to optional. So once that's done, we can go File, Build Settings, and inside of Build Settings here, we just want to click on the Build button, and this is going to ask us to save it to a location. We can just save it to the default location it gives us. This is just going to be inside of the project files, inside of the project folder. We can then click Build, and it will begin to build our app. Now, this isn't going to build directly to our device or create a file that we can just drag and drop onto our device. It's going to create a project for Xcode. Now, Xcode is another application that you do need on your computer, and that is just how we are going to convert these files into something that we can actually run on our device. You can download this off the App Store or on the Apple developer website. Now we should have the result of the build pop up in a new window. Here we have the AR Foundation test folder, and inside we want to double click on the unity-iphone.xcode project. This is going to open up the project inside of Xcode here. And inside of Xcode, we just need to tweak a few little things, first of all. So here we are in Xcode. Let's just click on our Unity-iPhone project over here. And in the center of the screen, it should pop up all the information for our application. There are a few errors, but we'll be fixing them soon. Just make sure that your bundle identifier here is the exact same as the one inside of Unity. This is important that they are the same. And then we can go Xcode and click Preferences. And inside of this window, we want to go to the Accounts. We want to go to the Accounts tab right here and click on the plus icon to add a new account. Now, we need an account in order to build to our device. So we're just going to select Apple ID, click OK, and then we just got to sign in with our Apple ID right here. And once that's done, you should see that it is now popped up in the list right here. So we're good to go. We can exit out of that window. And where it says automatically manage signing, just enable that. Click enable automatic. And a lot of the errors should go away. So we should only have one here. Click on the team drop down and select your team like so. All the errors should go away now, and we should be good to build it to our device. Now, to build, make sure you do have your device plugged into your computer and connected. And then what we can do is just click on the play button up here. This will begin to build and then run the app on your device. Alright, welcome back everyone. In this lesson we are going to set it up so that we can actually see the planes that are being detected. Because with AR Foundation, what it does, it uses the the camera and the sensors to basically determine different feature points inside of the world. It can detect feature points and track those. And with those feature points, it can then detect where surfaces are, such as tables or walls or floors, those sort of things. And then it can sort of generate meshes on top of those. And with those meshes, we can do various things such as shoot ray guns at them, throw objects so they can bounce off the table, all sorts of stuff like that. So what we're going to do is we are going to basically visualize these meshes. So we want to select our AR Session Origin object here, and we want to add the component AR Plane Manager. As you can see, this will give us a few things here. We've got the plane prefab, which is going to be the object that is going to be basically placed down as the plane. And then we have detection mode. We want to keep it on everything. You can make it so that it can only put planes on horizontal or vertical surfaces. We're going to keep it on everything for now. And then something we also need to do then is create the actual prefab for the plane. Now, AR Foundation comes with a base prefab we can create. So let's just right click here in the hierarchy, go XR, and we are going to select AR default plane here. And as you can see on this plane, it has a few things. It has a mesh renderer here already set up with a debug plane material. And it has a line renderer. And this line renderer just renders the border of the mesh for us like that. Now with this, what we can do is we are just going to save this into our assets here as a prefab. We can delete the one in the scene, and then on our AR Session Origin, let's just drag in and drop that into the plane prefab property like so. And now with this, when we actually test this out on our app, we should see that we actually can see the visual planes. We can see the planes on the walls, on the floors, on the surfaces, all that sort of stuff. Now what we need to do is set up our Android device to actually be able to have apps built onto it and connect to our computer so that we can transfer files over. So let's do that now. Okay, so what you want to do is you first of all want to go to your settings on your mobile device. Then you want to scroll right down to the bottom to About Phone. And then in here, we want to click on Software Information. In here, what we want to do then is just tap on our build number here 7 times. So 1, 2, 3, 4, 5, 6, 7. And what this does is we then have to enter in our current PIN. And then developer mode has been enabled. So we can go back to our settings, and if we scroll right down to the bottom, you'll see that we now have developer options enabled. We can open that up, and in here what we want to do is scroll down to USB debugging here. We want to enable that, and what this will allow us to do is connect our device up to our computer, and it'll allow us to build Unity games directly to our mobile and add that as an app. That's pretty much all we have to do on our phone. Now all we need to do is connect our device to our computer. Now that we have our device set up and plugged into our computer, what we can do is go File, Build Settings, and down here where it says Run Device, let's click on Refresh. And if you select this default device, you should see that your device is now here. If it's not, then go through the settings and make sure everything's set up properly on your mobile, and make sure that it is connected to your computer. So we can select our device there and click Build and Run. This will ask us to save this somewhere. I'm just going to create a new folder here. So let's call this one here our builds. Now the name of the APK doesn't really matter. It can be whatever you want. This isn't what's going to be called. This isn't what the name of the app is going to be. So I'm just going to call this our AR app. Click Save, and now it will begin to build to the device. So here we are, and as you can see, when we move the camera around a bit to the left and right, just to get that depth inside of the app, we can see that the planes appear. We can see the outline of the plane, we can see where they go, and if we move the camera down to the bottom, close to the ground, you can see that the planes are actually almost on surface level. You can walk around, the planes will start detecting more surfaces, and if we go back, you can see that the planes are still there. So there we go, we have the actual plane visualization set up. Now in the next lesson we are going to continue on working within AR Foundation, and we're going to actually set up a placement indicator. This is going to be used in many of the other courses that we're going to be going into, and this is going to allow us to pretty much have a sort of reticle or pointer inside of the AR world. It's going to allow us to place objects, and this is going to be done by shooting a raycast from the camera down to these planes. So I'll see you all then in the next lesson. Welcome back everyone. In this lesson we are going to be setting up our placement indicator. This is going to be an object that is going to basically be looking at whatever you're looking at in the AR world. It's going to be a little icon that's going to follow all around on the AR planes that we were detecting in the previous lesson. And this will be done by shooting a raycast from the camera down towards the AR planes. If it hits one, it'll detect the position and rotation of the plane, and then set the placement indicator to be that position and the same rotation as the plane. And with this, we can then do many different things. You could maybe have it so it can spawn different items on top of the indicator. You can also make it so that it could be a sort of tracking thing. Maybe you could have some objects follow around, walk around the AR world following the placement indicator. So the first thing we need to do is import the assets that we'll be needing. If you do wish to get this already made, we have the placement indicator up on GitHub available. The link for that will be down in the lesson summaries, so you can download the entire placement indicator project. It'll include the textures, the material, the script to manage and have that run fine. So once we're back in the editor now, let's import the assets we need. So first of all, what we need is going to be our placement marker base. This is going to be the texture that we're going to be using for this. It's just like a nice little blue ring that has a glow. And to enable that, we can just enable alpha is transparency, so that all the alpha values are going to be transparent. Hit apply, and there we go. We have the placement indicator set up there. Now what we need to do is create a brand new material. So I'm going to right click on the project window, go create material, and this is going to be called our placement indicator material. Now for this material, what we're going to do is we're not going to use the standard shader because we don't really need lighting, shadows, or any of that sort of stuff, so we're going to keep it a bit more simple. So let's change the shader from standard to unlit texture. Drag in the placement marker texture right there, and there we go. Actually, we need to change this from unlit texture to unlit transparent so that we can actually see the transparency. Now with this, what we then want to do is create a new empty game object here in the scene. Set the position to 0, 0, 0. I'm going to call this one our placement indicator. And as a child of this, we want to create a new plane. So I'm going to right click on it, go 3D object plane. We can remove the mesh collider as we don't want any sort of collisions with this. And as you can see right now, it's pretty large. Let's drag on the material, and there you go. And yes, as you can see, it is fairly large. So if we don't want this taking up the entire room, we can actually scale this down. Let's see what 0.1 looks like. This might still be a bit too large. I think we do need to bring this down a bit because even at 0.1, this is going to be fairly large in the real world. So let's actually bring this down to maybe 0.02 by 0.02 by 0.02. And there we go. That looks alright. So of course, you can test this out. You can hop inside it, build this to your app, build this to your device, test it out, see if it needs to be bigger, smaller, or whatever really. You can change the sprite, you can maybe make it a 3D object even, but for us, we'll keep it like this. And over on the mesh renderer component here, let's actually disable receive shadows and turn cast shadows from on to off, as we don't need to receive any shadows or cast any shadows. It's going to increase the performance slightly. Might not be noticeable, but it's always good practice to disable shadows on objects that you don't need them on. With this now, what we can do is create a C# script, and this is going to be the actual script that is going to manage it. It's going to be detecting all of the raycast hits. It's going to be placing the indicator around. And for this one, we are just going to call this one our placement indicator. Hit enter, and then let's attach it to the placement indicator empty game object here. And now we are ready to go. We can then just double click on the script to open it up inside of Visual Studio. And here we are inside of Visual Studio. We have our placement indicator script right here. Let's just delete the start and update functions as we won't really be needing them right now. And actually, before we go, let's hop back inside of Unity and disable the mesh visualizer, because at the moment we know that we have the meshes that are being built. We know that is working fine. So we can actually select our AR session origin and just remove the AR plane manager component like so. Okay, so in the next lesson, we are going to be scripting our placement indicator, setting that up and seeing if it works inside of our AR app. I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to begin scripting our placement indicator. So let's open up our placement indicator C# script right here and begin. First up, what we need to do is actually import some of the libraries that we'll be using for this. So first of all, we're going to be using unityengine.xr.ar foundation, and then we also want to be using unityengine.xr.ar subsystems, and this just has stuff like raycasting and some of the other features that we'll be needing for AR foundation. Now we can create our variables. First of all, what we want to do is we want to have a AR raycast manager component. This is going to basically run the raycast. It's going to be calling the raycast, sending them off. So before we continue, let's actually go back to our script, back to the editor. Let's go to the AR session origin here, and what we want to add in is going to be an AR raycast manager. And yep, we got that all set up now. Back in our script, we can create a private variable to keep track of it, because we are going to be needing to access it whenever we want to detect if there is a place for this indicator to go. So we'll go AR raycast manager. We'll just call it our ray manager here. Now we're not making it a public variable. That way we'd be able to just drag and drop it into the editor that way. We are going to make it private because we are going to be accessing the component. We're going to be getting the AR raycast manager component inside of the script. And after this, we have one more variable, and that is just going to be the game object visual. This is going to be the plane object that we created with the material of the placement indicator on it. And the reason why we need this, because we're not going to be moving it around. All we're going to be doing with this is either enabling it or disabling it, because if we don't have a plane detected, then we want to just hide it. We don't want it to be visible in the wrong position. Okay, so now inside of the start function, which gets called right at the start of the game when the script is initialized, we first of all want to get the components, and to do this we are just going to start with the ray manager here, and this is going to be equal to find object of type. And the type of object we want to find is going to be the AR raycast manager. So this will look through every object inside of the scene and try and find a component AR raycast manager. Then for the visual, we just want to get the child of this object. So we can just go transform.getChild 0.gameObject. And with this getChild function, you have to input an index. So the 0, so this means the first child. If we had 3 children, for example, then we could go 0, 1, or 2 to get each of those children. And now what we want to do also in the start function is by default, we want to hide the placement visual. So we want to basically disable the visual, so visual.setActive false. And yeah, because we don't want it to be visible at the start, otherwise it'll be in the center of the camera. It'll look a bit weird for the first few frames. So yeah. Now we're going to be working inside of the update function, which gets called every single frame. And this is where we're going to be shooting the raycasts, checking if they hit something, and if they did, update our position and rotation. So first of all, what we want to do is we want to shoot a raycast from the center of the screen. And to do this, we're not going to be using Unity's raycast system. Instead, we are going to be using the AR raycast manager system. And the way we have to do this, first of all, is we are going to create a list of AR raycast hits. We're going to call this one our hits, and this is going to be equal to a new list of AR raycast hit. Now, whenever we raycast with the ray manager, with the raycast manager, it doesn't output as a raycast hit as you traditionally would with Unity's inbuilt raycast system. Instead, this outputs a list of AR raycast hit, which just contains information such as the object we hit, the position, rotation, the normal position, the distance, all sort of information that we would want, depending on what we want to do. So, now that we have that list created, we can send off the raycast, we can cast it, and to do this we can just go raymanager.raycast, and in here we need to give it a ray, or instead of creating a new ray, we can just go screen point here, so a vector2, and input a screen point. Now on the screen, we want to be emitting it from the center of the screen, and to get that, so I'm just going to go new vector2 here, to get the center of the screen, because many different screens have different sizes, different pixel resolutions. So what we can do for the X is get the screen.width divide by 2, and for the height we can go screen.height divide by 2 as well. Comma after that, after the vector2. Now we have to give it the list of AR raycast hits that we want to output to. So we'll give it hits. And then over here we have to give it a trackable types. By default it's all, but for what we can do, we can just go trackable type dot planes. So this will just detect planes. In the previous lesson where we looked at actually the visualizing these planes, that is what we are going to be detecting. So we can add a semicolon at the end of that. And now what we can do is check if we hit an AR plane, then what we want to do is update the position and rotation of our object here. So the way we can detect if we hit anything is by just checking if this hits list right here, if it has a count of more than 0. If it has a count of more than 0, then that means we hit something. So if hits.count is greater than 0, then what we want to do is we want to set our transform.position to be equal to hits 0.pose.position. So this will get the first element of the hits list right here, access the pose, and then get the position of where that hit landed. And then we can do the exact same for the rotation, so transform.rotation equals hits 0.pose.rotation, and there we go. Now what we want to do is enable the visual if it's already disabled, because remember up here in the start function where we disabled the visual by default, we want to enable it here. So we'll go if visual.active in hierarchy. So if this is not currently active, then we want to enable it. So visual.setActive true. There we go. So we're enabling the visual right here. And that is pretty much it. So let's just have an overview of this script and see what it does. So up here we are getting the raycast manager and the visual components. Then we are by default disabling the visual as we don't want it to be in the middle of the camera when we open up the app. And down here, every frame, we are basically shooting a raycast from the center of the screen down in front of us. And if it hits a plane, if it hits one of the AR planes, we'll know that. And then we'll set our position and rotation to be where that raycast hit. And of course, then enabling the visual if it's disabled. So we can hop back inside the editor now. Make sure everything is good, we have no errors, that's all good. Make sure we have our script attached to the placement indicator right here. Now, before we actually build to our device, what we need to do is click on our AR session origin right here, and we need to add in another component. We need to re-add in the AR plane manager, as we weren't actually meant to be disabling that before, as this is required in order to actually detect the planes. We can leave plane prefab as none, and this will just generate a default plane object here, which is invisible. We can't see that, and that's what we want. So now that we have this done, we can go up to File, Build and Run, and then build our app to our device and test it out. So here we are, and as you can see, it snaps in like so. We hit the placement indicator, now tracking our surfaces. As you can see, I can get close, it gets bigger, and it looks like it's in the world. It follows along the surfaces as we move around, sticking to the center of our screen. We can go out pretty far, we can come right in close again, and yeah, so this is just going to be the basis of basically having a sort of reticle inside of the AR world. And there we go. In the next lesson, we are going to be just adding a little bit of functionality to this placement indicator. We'll be setting it up so that when we tap on the screen, we can actually spawn objects on top of the placement indicator inside of the world, so that when we move around, those objects will stay where they're created. So I'll see you all then in the next lesson. Welcome back everyone. In this lesson we are going to be creating a script that basically spawns objects on top of the placement indicator whenever we tap on the screen. So let's go down here to our project window and I'm going to create a brand new C# script, and let's just call this one our object spawner. We can create then we can then create a new empty object here. I'm going to call this one our object spawner, and this is just going to be a container object that is going to basically hold the script. So we'll just drag it there, and we can then open it up inside of Visual Studio. Now the first thing I'm going to do is add in a few variables. The first variable is going to be the actual object that we want to spawn, so we'll create public game object to spawn, and then we also need to then have the placement indicator. We need to know what the placement indicator is, where it is, for when we start spawning objects. So I'm going to create a private placement indicator variable right here, which is going to call this one our placement indicator. And now down inside of the start function, what we want to do is get the placement indicator component. We need to find that in the scene, and to do that, it's going to be very similar to back in this script here, the placement indicator script, where we got the array manager right here. So we are going to use the find object of type, so equals find object of type, and that is going to be of type placement indicator. So we're going to search through the scene and try and find an object that has the placement indicator component on it. And once we get that, we can go down to the update function, and here is where we can check for touch inputs. So what we're going to do to check for a touch input on the screen, what we can do is go if input.touchCount is greater than 0, because we only want to be able to checking this if our actual touch count on the screen, so how many fingers, how many touches are on the screen currently, is greater than 0. And we then want to check, okay, so if we have a touch count greater than 0, that means we have touches on the screen. Let's then get the first touch and check if this is the first frame that it is being tapped down. So we can then go input.touches, and this is an array, so we want to get the first element of the array. We want to get the first finger on the screen, that is 0. Dot touch phase, dot phase equals touch phase dot began. So are there more than 0 touches on the screen? And if so, is the first touch on the screen, is this the first frame that this touch is being pressed down? Because we don't want it to spawn every single frame the finger is down on the screen, as you know, that'll probably make quite a few performance impacts. So we got that here. Now what we can do is instantiate our object to spawn on top of our placement indicator. So I'm going to create a variable here, a game object, and I'm just going to call this one our obj. It's going to be equal to instantiate, and we want to instantiate the object to spawn, and where we want to instantiate it is going to be on top of our placement indicator. So placement indicator dot transform dot position, and for the rotation we will just keep it to let's actually match the placement indicator. So we can then go placement indicator dot transform dot rotation. There we go. We have created our object right here with instantiate. Let's actually put this on a new line like that. Actually, we'll put it, yeah, like that there. Okay, so we got this set up and ready to go. Let's now hop back into the editor right now, and we need to create an object to spawn. Now for this example, we'll probably just use a cube. So what I'm going to do is create a new empty object, call this one our cube object right here, set the position to 0, 0, 0. Now the reason why we are not just having a cube object here is because we want the center position, we want the pivot point of this object to be at the base. Because if we're spawning it at the position of our placement indicator, we don't want the center of the cube to be down here. We don't want half the cube to be underground. We want the cube to be sort of sitting on top of the placement indicator. So then as a child of cube object, let's create a new 3D cube here. Let's remove the box collider component as we don't need that. And I'm going to scale it down to 0.1, 0.1, 0.1. There we go, and as you can see by default this is in the center. So what this would mean is that if we were to spawn it, it would spawn halfway in the ground, which is something we don't want. So let's move this upwards by 0.05. So now that you can see it is sort of sitting on top of the placement indicator, which is what we want. So with this cube object, let's just drag and drop this into the project window to save it as a prefab. We can delete the cube object in the scene, And then on our object spawner component right here, we can drag in the cube object as a property of the object to spawn, save that, and now if we build it to our device and test it out, we should be able to spawn cubes in the world. Okay, so here we are, we got the indicator, and if I tap on the screen, you can see that I am now creating cubes. These cubes stick to the exact same position that they are in inside of the world. I can create many more close to the camera, a bit further away, and yeah. And that concludes our course. So, thank you very much for following along, and I'll see you all in the conclusion. Congratulations on finishing the course. Let's have a look at what we made with AR Foundation. First of all, in this course, we learned about AR Foundation and how to actually set it up inside of Unity. It's the amalgamation of both the ARKit SDK from iOS and the AR Core SDK from Android. And Unity pretty much combines these two together in a way that for the end user developing their app, it's a lot easier, so you don't have to worry about making an app specifically for one device or the other. You just make it for Unity, and then Unity does all the behind the scenes work in actually making it work with specific devices. We learned how this works. We looked at actually creating planes on the surface inside of our app, so we can see how the app actually creates these planes, where it creates them. And then we also created a placement indicator that actually detected where these planes were and placed it corresponding to where the actual raycast hit happened on the plane. Now, as I mentioned at the start of the course, the AR industry and AR Foundation inside of Unity is an ever-evolving technology that is continuously being updated and having further additions added to it constantly. So I encourage you to go out and look at whatever new sort of AR technologies there are, as there are definitely going to be more as time goes on, and the technology is only going to get better. Zenva is an online learning academy with over 500,000 students. We feature a wide range of courses for people who are just starting out or for people who just want to learn something new. The courses are also very versatile, allowing you to learn really whatever way you want. You can choose to follow the online video courses, read the included lesson summaries, or even download and follow along with the instructor with the included project files. Thank you very much for following along the course, and I wish you the best of luck with your future augmented reality apps.